So let's do this warm-up. We have 3 integrations for you guys to work on. So pause the video and give them a try. See if you guys get the same thing as me. So let me talk about the first two first. So the integral of this would be 2x cubed minus 3x. And when you have the limits of 1 and 3, you first plug in 1, and then you subtract it when you plug in 3. And I've ended up with negative 46. So make sure you got the same thing as me. If not, see if I did a mistake or you did a mistake and fix it. For the second one, the integral of cosine of 3x is 1/3 sine of 3x. I did a quick double check, see if I took a derivative of sine of 3x, 1/3 times that, if I would go back to cosine of 3x. So I'm pretty sure I'm right on that. Plugged in pi over 3, which is this, plugged in pi over 6, which is this, subtracted the 2. I ended up with negative 1/3. I know that sine of pi is 0, so that would just go away. And then the sine of pi over 2 is 1, so 1/3 times 1 is just 1/3. So, leaving us with this one. So this is going to be a classic U substitution. So give this one a try and see if you got the same thing as me. Alrighty, letting u equaling x squared plus 3 will give me du equaling 2x dx, meaning I needed a 2 here and a 1/2 there. So this now becomes du, this becomes u, giving us this one right here. Now what I did is I didn't want to worry about plugging back in for u, so I went ahead and changed the limits of this integral according to this equation right here, meaning that if I plugged in 1, let me use a different color, if I plugged in 1 into x, I would get 4, which is why I put 4 right there. If I plug in 3 into x, I would end up getting 12, which is why I put 12 here. Double check, so 3 squared is 9, 9 plus 3 is 12, so yeah, 12 would be it right there. I went ahead and didn't worry about putting the absolute value around u, given that natural log of 12 or natural log of 4 would both not give you a negative. They're both not negative, so there's no need for an absolute value around u. So my final answer would be, well, not final answer, so 1/2 natural log of 12 minus natural log of 4. And because I know properties, I know that this will be the same thing as natural log of 12 divided by 4, otherwise known as 3. Just mental check, because I do tend to make mistakes, especially if I do stuff live. So 12. So that's natural log of 12. 4, that's natural log of 4. Subtraction would make it a division thing. 12 divided by 4, it should equal 3. Does it? Yes, it does. Alrighty. And then you can also go further and say that you can move that up there. So you can be like natural log of square root of 3 if you want. I don't think you need to. So either this one, oops. No, I didn't mean to. Let's rewrite the 1/2. Okay, highlighter. Okay, either this 1/2 natural log of 3 or natural log of square root of 3 would do. Either one of those will be the answer. Of course, I could have made a mistake, so just make sure I didn't make one. Let me know tomorrow if I did. This problem is very interesting. So you ended up with a differential equation dy dx of 2 sine of x, and when you multiply dx on both sides, you're going to have one side which is going to have a function, and the other side doesn't really. It just has a dy, which is fine because you can still do the integral of just dy. And so here it will be multiply dx on both sides to get the x's on one side, the y's on the other, do an integral on both sides, and then what's the integral of 1? It would simply be y, which is very convenient. I didn't bother writing 2c's, so this is the combination of the 2c's. We talked about that in the previous video. And then we want to find out the initial condition, which is stated right here. When you plug in pi, you get 1. So plug in pi and plug in 1 for y, you end up with c equaling -1. And then you just rewrite your equation, which was option E. So that's that one. That one was probably the easiest differential equations I've done in a while. Let's move on. This one is going to be a lot tougher because we have a y, which we're going to have to divide on both sides, and e to the y, and then multiply dx. So the right integrals should be easy because you just do this one, but then we have to deal with the e to the -y or something. So Let's see. Well, I didn't even read the question. What does the question say? Consider this equation. Boom. Let y equal. Okay. Okay. Pass through 1, 0. Oh. Let y be a particular solution to the differential equation. Okay. Write an equation for the line tangent to the equation, and that goes to that point. Use a tangent line to approximate. Oh, okay. So there are a lot of concepts right here. There are a lot of concepts right there. Alrighty. So this is pretty much how we do linear approximations as well, because the linear approximation line is centered around here. 1.2 is close enough to 1 for it to be kind of valid. So let's do this. Given that we already given the slope, we don't really have to do much except find out what this is. So, and we also know that x is 1 and y is 0. So let's plug those things in. Where did they do it? They must have, okay, there we go. They did it right here. That's usually what I do first. I don't really do that first. I usually do the slope first. So plug in 0 for y and plug in 1 for x. So if I plug in 0 for y, I end up getting 1. And then for x, that was x squared and then x. So that's going to be 3 minus 6. 3 minus 6. So 1 times negative 3. So the slope ended up being negative 3. If you didn't catch what we just did, we took the dy dx equation, just the way it is. Didn't separate variables like I said we were going to do in the beginning. Just plug in 1 and 0 because we know what 1 and what x and y is going to be to get the slope. Then I would actually write this down, plug in stuff I know. The slope is negative 3. The y1 should be 0. x1 should be 1. And then solve for the tangent line. Now, we got this equation right here. Plug in 1.2 into this equation. We get negative 0.6, which would be your estimation. Alrighty. They have a grading guide, which I encourage you to look at to make sure that all of these points are attained. Alright, let's move on to the next one. Alrighty, so let's do this one. Consider the differential equations, bam. Let y equal f of x be the particular solution to a differential equation that passes through 1, 0. Okay, so we're probably going to look for this particular solution. When you do these differential equations, a lot of equations could work for this one, but when you have a particular solution, it's 1y with this sample point, because there are many possibilities, because you have that c you end up with. When you do the integral on both sides, there's usually a c. So when you plug in this, is you're finding a particular equation that works for this. Anyways, we're probably going to have to separate this. So whatever I said in the previous slide will actually happen right here. Yep. So find the particular solution to a differential equation that passes through 1, 0. So we want to get these separated. So divide by e to the y on both sides, multiply by dx on both sides. You're going to end up with integral equaling an integral. So e to the negative y, do that. The e to the y's are really easy. You just have to worry about that negative. And then this integral isn't too bad either. So integrate both sides. You're going to end up with negative e to the negative y equaling x cubed minus 3x plus c. We want to get y by itself. Or actually, at that point I would have probably plugged in to get c. I guess it makes it easier to have it e to the negative y first. So that gets you right here. You didn't have to do this step. You could have found c right here if you wanted to. But doesn't matter. So now let's look at the initial condition given. That was the initial one, so plug it in. Wherever you see a y, you put a 0. Wherever you see an x, you put a 1. You're going to end up getting, let's see. Yep, you're going to end up getting c equaling negative 1 because that e to the 0 is 1. So plug that in. Now we can solve for y because we need to get y by itself. So natural log both sides and divide by negative 1. You're going to end up getting this. Don't really see a way to simplify that one. You could have probably moved that negative as an exponent if you wanted to, but you don't really need to do that. Now that you have done that, consider the consider the grading guide for the AP question, how an AP grader would have graded you. That being said, we are done. See you guys tomorrow.